Hey, how's it going? My name is Sean, and today I'm going to be walking you through DealQ, which is the underwriting platform for commercial real estate that I co-founded and was the CTO of last year. I built and architected this entire code base myself into production. We ended up running a private beta with multiple enterprise customers, and so it was built with their needs in mind, but ultimately decided that the business model wasn't the right one to pursue, and so ended up shutting down the startup. With that being said, I'll give you a quick overview of what the platform is, a demo of the product, and then we'll jump right into the code base, and this whole thing should take no longer than 5 minutes. Here from the DealQ dashboard, we're going to go ahead and upload a deal. We're going to label each of the three documents, and then we're going to press upload. And the back end is extracting the data and structuring it. And as it returns, you're taken to a verification flow where you can look at the rent roll data, the OM data, and compare it side by side with the source documents and make changes as you see fit. We have a 99% accuracy rate for every document that we process. Here, let's take a look at the T12's NOI number, 691,383, 691,383. As you can see, each line item has been categorized already, including the subtotals, which means that this process, which used to take 2 hours, is now under 5 minutes. And voila, you've got a completed Excel model, your custom Excel model, populated with all the relevant information in underwriting. And if you want to reach an investment decision even faster, you can go straight to the deal summary screen, which has an underwriting playground where you can model out different investment scenarios. Sweet. So now I will give you a overview of the tech stack, sort of the system architecture for the back end and the front end, and then I'll walk you through how I designed one of the extraction pipelines, just so you get an idea of how I think through problems and what sort of engineering went into this. So for the front end here, we used Next.js, Zustan for state management. For the back end, we used Fast API and then LangChain for coordinating the LLMs, Redis for caching, Codebase for database and S3, and then Stripe for billing. Reason why I chose Fast API and not going with the full TypeScript stack is because we needed a library called PyMu PDF, which was working really well with data extraction from the docs. So I just ended up going with that. In terms of infrastructure, the product was deployed on DigitalOcean droplets, containerized, and then we used GitHub Actions for the CI/CD. System architecture. So the front end sends requests to the back end, and then the back end is split into three separate layers. We have the routing layer, which is just HTTP request, the orchestration layer, which manages services, which are pure stateless functions. Reason I did it this way was twofold. One is that the services being independent of each other allows for easy modular testing. And number two is so that later when we switch to an agentic workflow, we could just call the orchestration functions as tool calls. Now to finish off this video, I'm going to show you how I problem solve using the rent roll pipeline design as an example. I always start by framing the problem, then defining the criteria for success for a solution, and finally iterating on the solution, starting with the simplest one and only adding complexity if there are issues that arise. The problem here is that the rent roll document contains valuable information about hundreds of units, but it also contains a ton of noise like inconsistent formatting, duplicate information, and row level inconsistencies as well. We need to create a system that can accurately pull out the information in a structured fashion with the same accuracy as a real estate analyst and in a fraction of the time. The criteria I defined were accurate, complete, meaning no units missing, consistent, meaning we get the same result every time for the same document, stable, and fast. It's got to be faster than a real estate analyst doing it, and it shouldn't be disruptive to the user's workflow. I went through maybe 5 or 6 iterations of this, which started with just trying to one-shot the solution by passing it into an LLM call. Obviously, this did not work, especially at a time when the models were a lot weaker. And so we eventually reached the final version of the pipeline, which involved getting the boundaries of where the relevant information was from the LLM, and then using regex, pulling that out, and then splitting that across a bunch of calls which ran concurrently, and then just combining all the data at the end. I tested this pipeline on hundreds of deals, and it worked 99% of the time with accuracy. Also included the data adjustment user interface, just so people felt like they had more control, which mattered especially in the financial modeling world. And lastly, I changed the output to be from a JSON to an array of arrays, which saved a ton of token usage and return time. If you made it this far, thank you for listening, and please let me know if you have any questions.